Hi, today I'm going to discuss about the topic convolutional codes. This topic comes under in convolutional codes and applications in fifth unit, information coding techniques. And convolutional codes nothing but reliable data transmission for modern digital communication. This is called convolutional codes. Here, icebreaker, the Whispering Gallery. Can you hear me now? Imagine sending a critical text message during a chaotic monsoon in Mumbai. Electrical noise and physical barriers interfere with the signal. The key point is how do we ensure the receiver gets the exact message even when the channel is noisy? Empathizing with the engineer. Here meet Arjun. He is a system engineer designing a deep space probe for ISRO. Arjun's challenge is not just sending data. It is the fact that data gets corrupted across millions of miles. He needs a way to build memory into the code so the receiver can guess the correct bit even if some are lost. Defining the problem, memoryless versus memory. Here, block code is data sliced into fixed blocks, no interblock correlation. Example is Hamming codes. Convolutional codes are operates on continuous streams. Output depends on current or past bits. Superior streaming error correction. Here, ideate phase, the shift register approach is the solution. We use shift registers and modulo to address. By sliding a window over the input data, we create a mathematical fingerprint of the sequence. Constraint length declared as k variable. Number of stages in the shift registers, that is k. Code rate is R. Ratio of input bits to output bits. Example 1 bar 2. Prototype phase, visualizing the trellis. The trellis diagram is the most powerful way to visualize convolutional encoding. It shows all possible state transitions over time. Remember, each path through the trellis represents a unique encode sequence. Here, the knowledge encoding process is what is the correct sequence of events when a bit enters a convolutional encoder? Four options are the encoder performs modulo 2 addition based on generator polynomials. Option 2 is the encoded output bits are transmitted over the channel. Third is the register shifts all bits one position to the right. Fourth option is the bit enters the first stage of the shift register. The answer on the next slide. What is the correct sequence of events when a bit enters the convolutional code? The first option is a bit enters the first stage of the shift register. Second one is the encoder performs modulo 2 addition based on generator polynomials. The encoded output bits are transmitted over the channel. The register shifts all bits one position to the right. This is the order for encoding process. Here, horizontal breadth global impact. Convolutional codes are not just the textbooks, they power the modern world. Deep space, Voyager and Mars rover missions, wireless 4G, LTE, and 5G standards, broadcasting, digital video broadcasting. Summary and mind map, structure and tools. Here, registers, adders, trills, and state tables. Decoding and matrices are Viterbi algorithm, free distance, and D-free. Here, final reflection or assessment. If you are designing a communication system for an underground metro with high interference, would you choose a higher constraint length, that is k, or a higher code rate, or why? Final reflection and assessment, you might have said, here K improves error correction via increased bit memory, lower code rate or adds redundancy, aiding high noise area like metros. Trade-off, increasing K rises with be decoder complexity. Conclusion, higher K is preferred for interference so if hardware handles log. Thank you for watching this video.